This video has been created to provide you with useful information about the use of large building, high-volume mobile desiccant drying equipment. We hope to share with you some of what we have learned about the science of drying buildings. It is produced as a means to familiarize you with some of the challenges that we encounter when drying buildings or commercial spaces that have been damaged by an unwanted water intrusion event. We will cover three main topics in this video. The capabilities of the 6,000 CFM high-volume mobile desiccant drying system. The comparisons between using the 6,000 CFM mobile desiccant dryer and the use of 200 CFM portable refrigerant machines. A comparison between the desiccant drying technology and refrigerant drying technology. The business of effective high-volume drying. Let's summarize what we know and what must be done when a large commercial building or an entire new home has been saturated with a water intrusion event. Containment. Stop the leak first. Once the leak has been stopped and prevented from recurring, it is important to begin the drying and dehumidification phase as soon as possible. The science of drying buildings. The job must first be analyzed in order to calculate exactly how much volume of air must be exchanged per hour, so as to make every effort to return the affected space to pre-loss condition. Using specifically designed inspection meters and investigation tools, the technicians determine the extent of the damage and evaluate the components, carpet, pad, floor, furniture, structure, and calculates the remediation probability. Only then can a correct course of action be determined. The 6,000 CFM mobile desiccant dryer can process up to 360,000 cubic feet of air per hour. With the use of this machine, it is not necessary to have a portable generator unless there is no electrical supply in the building. The 6,000 desiccant is designed primarily for large commercial drying projects. Operating under constant heavy humidity conditions, this machine can remove between 350 and 800 gallons of water a day. The machine will draw 50 to 60 amps and 208 volts, which can be made available through a licensed electrician attaching the wires directly to the main electrical panel with a breaker of most buildings. The 6,000 desiccant works by drawing in outside air. Most Bay Area air averages about 70% humidity. When the air is expelled into the structure, the target humidity level is less than 2%. Compare this to the Sahara Desert, which averages 25% humidity. We know that an average 2,000 square foot home contains approximately 20,000 cubic feet of airspace. Therefore, by applying simple division, we maintain that the air in the average 2,000 square foot home can be exchanged 18 times per hour. Remember, the 6,000 desiccant will process 360,000 cubic feet of air per hour. Our optimum air volume exchange rate target is 1 to 4 times per hour. This means that the total volume of air contained in a 2,000 square foot home is exchanged 18 times per hour. This is an extremely high value number that is 14 times more air exchanges than is necessary for drying the average 2,000 foot home. Because of this calculation, we know that we must adjust and monitor the machine to be sure that we do not dry the building too quickly. Added to our calculations, we must consider the type of material we are drying. Stucco, drywall, wood, concrete, or various porous materials will dry at different rates depending on the denseness of the material. Please note, if the extent of the water intrusion is small, it may be necessary to use smaller portable desiccants. In this case, the 300 CFM to the 900 CFM desiccant may be the best course of action. Theoretically, we could dry multiple homes at once with the 6,000 CFM mobile desiccant drying system. It's just that powerful. We can comfortably dry buildings with 32,000 to well over 100,000 square foot of commercial space. Of special importance, we can accomplish this drying task with minimum business interruption to the tenants. It is important to realize that if a water problem is treated quickly, the dry-out process will prevent mold, mildew, and various types of bacteria that are present in standing water, drywall, structural components, carpet, and other porous materials found in buildings. Ideal Drying has taken a position of a no-conflict service policy, which means that we do no reconstruction. However, we will provide a controlled demolition in order to make the job ready for the drying phase. We do not have a motive or initiative to sell carpets, floors, or other goods and services associated with reconstruction. We specialize in drying your structure only, but we can offer names of services we feel are reliable for reconstruction if requested. A common question would be, how safe is it to leave your machine running for hours and hours next to my commercial building? The answer is, there are circuit breakers and fuses built into the unit that will shut the entire machine down if too much heat is built up or if one of the components inside of the 6,000 desiccant becomes unstable. The machine has a UL-approved electrical panel that will ensure the optimum safety standards. The diesel fuel-fired reactivation chamber that is the heat-generating component of the 6,000 desiccant dryer. It is reliable and safe inasmuch as the internal sensors within the machine will shut the system completely off if a problem should arise. Comparing the 6,000 CFM desiccant and the 200 CFM portable refrigerant units. On a one-to-one comparison, the smaller 200 CFM refrigerant units are clearly more economical when used for small water losses. However, the 6,000 is more economical, faster, and the job is completed with less electrical usage and less total equipment usage when used for a larger job. Each job is uniquely different, and the ideal drying project manager can determine ahead of time which drying method is the most economical and fastest method to use. Comparing the desiccant drying technology to the refrigerant drying method. Cold weather makes refrigerants work less efficiently. The optimum temperature for a refrigerant is above 68 degrees. Below 68 degrees, the refrigerant will work less and less efficiently until it stops working to any appreciable result below 40 degrees. The desiccant will work at all Northern California temperatures, including temperatures below freezing. The desiccant will also produce a relative humidity approaching zero, which is a humidity rarely found in most deserts. With temperature variances in mind, the desiccant will usually dry faster in an overall rating when compared head-to-head with the refrigerant drying system. The other advantage is that the desiccant is constantly pulling in fresh air from the outside and therefore is not simply recirculating the possibly contaminated air inside over and over. The result is that the refrigerant dryer will usually produce a stale odor while operating within the containment field, while the desiccant, constantly using clean, fresh air, will produce no stale air. We hope that we have provided useful information about the desiccant drying system. The following is our summary. No dangerous propane fuel. It's economical. Does not require a generator, but will work with a generator if necessary. The 6,000 mobile desiccant drying system requires 50 to 60 amps to run, while the equivalent number of 30 refrigerants would take over 300 amps. 30 refrigerant dryers, the unit cost is $3,300 a day. 6,000 mobile desiccant dryer equals $1,600 per day. Minimum business interruption and minimum interruption to employees or tenants. Will work efficiently in any Bay Area temperature. UL-approved electrical panel. The main uses: environmental drying, support drying for mold remediation, building envelope drying, including whole house wet new construction. In conclusion, we would like you to be assured that Ideal Drying has the expertise to approach each water loss with the most proven methods pertaining to the science of drying.